In this video, we are going to look at switchgears and how we apply health index to this asset. Let us first look at degradation. The life expectancy of switches in enclosed switchgear is influenced by a variety of factors. The frequency of switching operations, the load, the presence or absence of a corrosive environment, and the presence or absence of dampness or moisture at the installation location are all aspects to consider. The switchgear can have a service life of 30 to 35 years on average, provided it is properly maintained. In the absence of specific difficulties, it is standard industry practice to run distribution switchgear until it reaches end of life, right before failure. A variety of intervention measures are used on a regular basis to extend the life of these assets and reduce in-service failures. So for example, inspection with thermographic analysis and cleaning with CO2 for air-insulated switchgear, etc. If faults or deficiencies are discovered during the inspection, the afflicted component can typically be replaced or fixed rather than having the switchgear completely replaced. Switchgear failures are frequently associated with external influences rather than being directly related to the equipment's age. Dirt or contaminations, vehicle accidents, rustings, and damaged insulators caused by misalignments while switching, for example, are the most common causes of pad-mounted switchgear failure. With excellent design and maintenance techniques, all of these problems can be avoided to a significant extent. Other flaws are significant and demand attention, but they do not cause failure and can be corrected in the field also. Graffiti on switchgear, for example, is typically regarded as an eyesore and may even obscure vital safety and operational signage. So it is normally possible to repaint the outside of the case and replace the signage without interrupting power flow or conducting an outage for that. Anti-graffiti paint may also be an effective remedy in regions where graffiti is a recurring problem for these switchgears. A rusted switchgear enclosure can also result in perforation, posing a public safety risk. Touch-ups and repainting may postpone the rusting process, but the equipment will eventually need to be replaced. Cleaning can often eliminate grime and pollutants that has been accumulated on the switchgear. Dry ice and online cleaning is a newer technology that is now in use to resolve this problem. However, I also wanted to talk about submersible switchgears. Now, due to the conditions in which they are used, submersible switchgear units are subjected to a lot of stress. And as a result, there are a variety of failure modes, and these include environmental factors, as the location of a switchgear unit has a significant impact on its life expectancy. Premature failure can also be caused by electrical stressors on it. Salt water, contaminants, UV radiation, and frequent wet and dry cycles can all lead to switchgear failures for the submersible switchgears. Ingress of moisture into the insulated unit will compromise its insulation. Moisture in oil has a negative impact on insulation because it introduces moisture as an impurity. The insulating qualities of oil are considerably reduced by moisture. Furthermore, due to its physical qualities, water that settles at the bottom of a tank might contribute to flashover. Moisture will cause potential acids to develop when SF6 is exposed to it. Corrosive acids can cause insulation failure and corrosion of the switchgear units inside. When moisture or air enters a vacuum switchgear system, the quality of the insulating material deteriorates, which has a negative impact on the unit's internal workings. Switchgear degradation can also be caused by electrical stresses. Currents introduced that are higher than the switchgear's rated current will add to a higher risk of degradation and failure. Insulation failure and flashover can both be caused by electrical discharges or surges. Electrical discharges in oil or SF6 might cause contaminants to form in the switchgear unit, causing it to degrade. Self-healing processes, on the other hand, are actually possible for switchgear. So for example, SF6 can disintegrate and totally recover, as SF6 gas can do that when exposed to an electric discharge. Solid insulation failure can result in lasting harm, though, by reducing the solid insulation's insulating qualities. And at normal operating voltage, this will eventually break. Finally, it's also possible that the drive mechanism that connects the contacts will deteriorate. When the driving mechanism is necessary, a buildup of deteriorated oils and contaminants may cause it to trigger slowly. Bearings and connections are also subject to wear and tear over time. Slow switchgear operation indicates that either maintenance is required or that the unit's end of life is approaching. After a number of operations, the electrical connections may actually deteriorate within the switchgear. Surface melting and erosion owing to heat stress, mechanical deterioration due to friction, and surface oxidization due to hostile conditions can all contribute to electrical contact degradation. Now, before we move on further into our course, let us take a brief look at our sponsor for this course. Now, as an engineer, especially when I first started in my career, I really felt overwhelmed the list of documents that we need to do on top of our technical work. Yet, these documents are very important in our career as it is the more prominent thing that displays our credibility to management and to our clients if we so decide to become an engineer consultant, which is where the real actual money is. Now, I don't have these tools available to me when I first started my career, but now PM Milestone has created this package of all the professional templates that you need so that you can focus more on the technical aspect of your career. These templates are tried and tested by real professionals, so you should feel confident in using them in your career to present your best foot forward in front of your manager or clients. These templates are also updated periodically, and I think their last update is just 2021, so they're not going to be out of date or context to the present times, as these people are serious in getting the most professional product to meet your needs. They're also very confident of the quality of these templates too, as they offer you their product completely risk-free with 60-day money-back guarantee if you are not satisfied with it. So, if you are interested in this product and would also like to support me in creating these courses on YouTube in the future, please check out their product using the link in my video description titled Course Sponsor PM Milestone 2.0. The condition of in-service switchgear is determined by a combination of service age, visual inspection, and infrared testing. Now, visual inspections of switchgear can review the following issues. First of all, SF6 leakage in SF6 insulated switchgear at any of the bushing metal interfaces, tank or piping interfaces, any corroded or loose terminations. You can also visually inspect any cracks or damage to the interface barriers, or visually inspecting any signs of rusting or damage to the tank enclosure as a result of dirt contamination or vehicle collisions, as well as if it is a submersible transformer. You can also look for signs visually as to any signs of the vault being compromised or that it needs to be fixed. So now let us look at the different categories that make up the switchgear's health index. The first one is service age. So with the rating of 4, it means that the switchgear is basically younger than 10 years of age. For a rating of 3, it means that it is aged between 11 to 20 years. For a rating of 2, it is between 21 to 30 years. For a rating of 1, it is between 31 and 40 years. And any switchgear that is above 40 years, we will give it a rating of 0. Now, next is the condition of the switchgear enclosure. So for the rating of 4, the switchgear should have no signs of rust on tank or enclosure or damage on the enclosure due to corrosion, dirt or contamination, or vehicle accidents. Now for the rating of 3, there are minor signs of the rust or some damage or dirt contamination or minor signs of vehicle accidents, but very minor. For the rating of 2, there are going to be significant signs of either rust, damage on the enclosure due to corrosion or vehicle accidents. And for the rating of 1, there are major signs of rust or that there's major damage on the enclosure due to corrosion or vehicle accidents. And lastly, for a rating of 0, there are serious signs of rust or that there are very high damage on the enclosure due to corrosion or vehicle accidents. The third category is condition of the interface barriers, and this actually only applies to the air-type switchgears. So for a rating of 4, it means that there are no signs of damage or cracks in the interface barriers. For a rating of 3, it means that there are signs of minor damage or cracks in the interface barriers. For a rating of 2, it means that there are signs of significant damage or cracks. For a rating of 1, it means that there are signs of serious damage or cracks. And for a rating of 0, it means that there are signs of serious, very serious damage or cracks in the interface barriers. The fourth category is the condition of terminations. So for a rating of 4, it means that the terminations are tight, free from corrosion, and show no signs of overheating whatsoever. And the cables are adequately supported and impose no excessive loading on the switchgear during normal or fault interrupting duty. And for a rating of 3, it means that there are minor signs of wear with respect to what I have just described. For a rating of 2, it means that there are significant signs of degradation, but they actually do not impact safe operation of the switchgear. For a rating of 1, it means that there are serious deficiencies with the terminations, and it requires repairs during the next scheduled outage. And lastly, for a rating of 0, it means that there are very serious deficiencies with the characteristics that I mentioned, and in this case, it would require immediate repairs or replacements. Then there is the fifth category, which is the condition of blades. And again, this is only for air-type switchgears. So for a rating of 4, it means that the blades are clean, free from corrosion, cracks, distortion, etc. All of the fasteners of the blades are tight, no visible evidence of looseness or loss of adjustments, etc. Right? So for a rating of 3, it means that there are minor signs of wear with respect to what I've just mentioned, but this is actually kind of expected as time goes on. For a rating of 2, it means that there are significant signs of wear with respect to the blades, but the deficiencies being inspected are actually not critical to the safe operation of the switchgear. For a rating of 1, it means that the blades are degraded and it is requiring replacement during the next scheduled outage. And lastly, for a rating of 0, the blades are damaged, degraded beyond repair, and it is requiring immediate replacement. And the sixth category is condition of operating mechanism, and again, it is for air type only. For a rating of 4, the operating mechanism is in good condition, no signs of overheating or deterioration, no evidence of moisture or insect ingress into the control cabinet, etc. So for a rating of 3, it means that there are normal signs of wear on the control components based on what I mentioned. And for a rating of 2, it means that there are significant wear on the control components, but does not affect safe operations of the switchgear. For a rating of 1, it means that there are unacceptable level of degradation of the control components and requiring component replacement or repairs during the next scheduled outage. And last but not least, for a rating of 0, the switch operated controls are actually defective or degraded, and this requires immediate replacement. Now the seventh category is the IR test, and like before, we only have 3 ratings, which is 4, 2, and 0 respectively. And we respected that. A rating of 4 means that there's no hotspots. Rating of 2 means there are noticeable hotspots, but they do not jeopardize safe ongoing operations. And lastly, for rating of 0, it means that there are very serious hotspots detected. Now the 8th category is the condition of the pad or vault, which in this case, in this category, it is assessing the pad condition if the switchgear is pad mounted, or it would be assessing the vault if it is submersible. And again, this only has 3 ratings, which is 4, 2, and 0. So for a rating of 4, it means that it's in good or mint condition, which means the pad or the vault is as good as new. For a rating of 2, it means poor condition, and that means that a remedial action is required. And lastly, for a rating of 0, it means immediate replacement is required. And this last category for the switchgear is only for gas-insulated switchgear, which looks at SF6 leaks as well as pressure gauge readings. So for a rating of 4, it means that there are no SF6 leakage at any of the bushing metal interfaces, tank or piping interfaces, as determined by inspection of the SF6 pressure indicator. For a rating of 3, it means that there are minor loss of SF6 gas pressure in the interruption chamber. For a rating of 2, it means that there are noticeable loss of SF6 pressures, but gas pressure still is within the manufacturer's safe level recommendations. For a rating of 1, it means that we have significant loss of SF6 pressure, but the gas pressure expected to remain within manufacturer's safe pressure level recommendations, and it could be done during the next scheduled outage. And for a rating of 0, it means that you got unsafe SF6 pressure, and this should require emergency repairs and or replacement. So now let us look at the health index weights. So as you can see here, one thing that is of utter importance, and this is only for gas insulation insulated switchgear, is the SF6 leaks, the pressure gauge readings. So we assigned basically of really high importance, so we give the weight of 4. And as you can see here, we gave the weight of 2 for service age, condition of enclosure, barriers for air type switch gears, and the condition of the pad. Now the rest, it is of lesser importance, which is the blades for and the operation mech for the air switch gear, the condition of terminations, and as well as the IR scan results. These are of less importance, and so we assigned the weight of 1 to it. So let us go over an example. Well, a 12-year-old gas insulated switchgear, which we gave a rating of 3 to the age, with significant signs of rust on the enclosure, which we gave a rating of 2, and minor signs of wear on the terminations, which is a rating of 3. With IR testing, there are no hotspots are detected, which we gave a rating of 4. And the pad of the gear is in poor condition, in which remedial action is required, in which we gave it a rating of 2. Now, there are no SF6 leak detected anywhere, which is a good sign, so we gave it a rating of 4 for that. And in this case, calculate the health index for this switchgear. So of course, we first need to calculate the score that we get for this switchgear's condition. So basically, we sum up the ratings that we obtained through this, multiplied by the weights of those respective categories. And in this case, our calculated score is 37. And then we could calculate the maximum achievable score by the summation of all of the weights times the maximum achievable rating, which is 4, so it equals to 48. So the health index would be equal to 37 divided by 48 multiplied by 100, so that equals to the value of 77. So as mentioned in the fundamental section, a value between 70 to 85 is considered good, and as such, there might be deterioration of some components, but in this case, only normal maintenance is required for this switchgear. Now, if you like this video, please don't forget to click like and subscribe to our channel. Our channel, the EE Bootcamp, has a wealth of knowledge regarding to the energy industry, so be sure to check it out. Also, this video is part of a playlist of the whole course, and so I've put the link to the playlist for this free course in the video description. As you may be aware, I'm a professional online instructor that teaches various topics regarding to the energy industry and offers certificate of completion at the end of each course. As you probably have noticed, this course needs fundamental knowledge in basic asset management. Physical asset management is important, and the skills are highly sought after in many large companies within the energy industry, or any industry that manages large asset in infrastructures for that matter. If you lack knowledge in physical asset management, look no further than my Physical Asset Management Fundamentals course offered at Electrical Engineering Portal, as in that course, I will provide you with the fundamentals that you need to kickstart your career in the physical asset management world. Another type of knowledge that you need for this course is fundamental information about the power distribution system. If you don't have enough experience in the industry, I would suggest you to enroll in my Distribution Power Engineering Fundamentals course hosted on Udemy, as in that course, I will walk you through the different parts of the power distribution system as well as basic design concepts that you will need to kickstart your career in the industry. Now, I have put the links to both of these courses in the video description also. Lastly, I have also included the link to my website in the video description that contains the information to all the courses that I offer, as well as other helpful resources that you may find useful in your career or in your learning path. Thank you, and I wish you good luck in your career. Remember, knowledge is power.